Right, in this class we are going to be talking about composite functions. From the previous videos that you must have watched on this channel on functions, you have seen that we mentioned in the last video that f of s is an explicit function. For example, if this is equal to x squared plus 2, for example, that means if I want to have f2, that will be 2 squared plus 2, and that will be 8. That will be 6. Now, but in this case, we want to do something that is in a composition form, which means that I want to combine two different functions together. That means one function will be defined with respect to the other one. So let's say we have fx as a function and we have gx as another function. So if this fx is defined with respect to this gx, then we call it a composite function. So a composite function can be of this form. You can write f into gx. Can be g into fx. It can be this, but don't forget that f to gx is not equal to g to fx. It's not equal. You need to note this, very, very important. They're not equal. All right, so let's take an example of what a composite function looks like. Let's quickly take an example of what this looks like. All right, let's see. Suppose we have a function fx equals to x plus 2. Suppose we have a function like this and we're given gx, that's another function, x squared, and you have to get f in composition with gx. What this simply implies is that, you know, this x is replaced by gx. That means this gx is occupying the position of x, and that will also apply to the function itself. So suppose we want to, instead of writing that x, we are going to write gx plus 2, and we already know that gx is x squared. That means gx is what? X squared. X plus 2. That will be how to solve this one. It's simple, right? Let's check another example for clarification. If I have something like this, fx that is equal to x squared minus x minus 1, and I have another function gx that is equal to x minus 1, another function like this. So what I need to do is, suppose you are asked to find f to gx. I will show you that f to gx is not equal to gx to fx with this question. So that means wherever I see x, I'm going to put gx. So here there is x in this place for this fx, so I'm going to put gx. There is x there, and also there is another x here, minus 1. So in that case, I have, what's my gx? My gx is minus x minus 1. So x minus 1 to the squared minus another x minus 1 minus 1. Okay, very simple, very, very simple and straightforward. Let's cancel this so we can have some space. Okay, I think we can still use this list. All right, so to expand this one, I'll have x squared minus 2x plus 1. You should know that from our basic arithmetic binomial theorem. All right, so we have minus, this minus, there will be a plus here. So minus times plus is minus. The minus times minus is plus. So I'm going to have x plus 1. Okay, so in that case, I'm going to have my final answer to be for f gx. The final answer will be this x squared does not have a like term, so we have x squared for this one and this one. That will be minus 3. That's 3. Then for this one and this one, that is plus 2. Now I want to check if this is actually equal to gfx. I want to quickly check if that notion is actually correct. So let's see some space here. Okay, so in a case where we want to find g to fx, I want to find g to fx. That means in the function of g, our g is x minus 1. We are going to put fx whenever we see x. So instead of putting this x, I'm going to be putting fx minus 1. That means it's representing this one. Which means, what's my fx? My fx is the whole of this one. The whole of this. So I'm going to write x squared minus x minus 1, which is the whole of this fx, then minus 1, this minus 1. Which means that I can equally write fx here is equal to x squared minus x. This becomes minus 2. You can see that this is not equal to this, which means that I can say boldly that f to the gx is not equal to g to the fx. Very simple, right? Okay, so let's see another example on this composite function. Let's see another example on this composite function quickly. It's an example so we can get more clarifications. Let's see my examples. Suppose we're given fx to 3x minus 2 over x plus 1, and we're given g x to 1 minus x squared, and you're asked to find f into gx with this question. Quickly, how to solve this one is very simple, which means that whenever I see x, I'm going to put gx. So f into gx here will be 3 into gx for clarification minus 2 over gx, because this is replacing this. Alright, so plus 1. This is also equal to 3. What is my gx? My gx is the whole of this. Alright, so I have 1 minus x squared minus 2 over 1 minus x squared plus 1. So let's open the brackets. We have 3 minus 3x squared minus 2 over 2, because 1 plus 1 is 2, minus x squared, which means that I can write my final answer for f to gx is equal to 3 minus 2 is 1 minus 3x squared all over 2 minus x squared. Very simple, right? Okay, let's take another example. Suppose with this same question you're asked to suppose you're asked to find gf1. let's say you ask to find G1. That means after you must have done this one, you have to put this value into your fx. So let's quickly find our G1. So G1 here means I'm going to represent the whole of x with 1, right? Very simple. So here, instead of writing this x, I write 1 squared, and this is obviously 0. So I can as well write this as f0, still acceptable because this whole thing here is 0. Therefore, I'll be having f to G1, which is the same thing as f to 0, and I can also write this as, because this 0 is occupying the space of x, so whenever I see x in this expression, I'm going to write 0. So I have 3 into 0 minus 2 over 0 plus 1, which is, this 3 times 0 is 0. So I have 0 minus 2 over 1. And that is minus 2 because this, what does I have this one. Okay? So very simple. And the last example, let's see one more example. Very, very, very simple. Still this same question. You should be able to do this one. Let's try this one. If you're able to do that. Suppose I want you to do something like G into F0. What will you have done? That means you need to find this first and then put your answer in the value of gx. So to find this here, I can actually get it. My F0 will be, put 0 here, put 0 here. That will be 3 into 0 minus 2 over 0 plus 1. And obviously that is minus 2, which means G into F0 is the same thing as writing G into it's the same thing as writing G into minus 2 into minus 2. And how do we do this? That means we're going to write this, because this one here is like replacing this x with this minus 2, which means my final answer to get this is 1 minus 2 squared, and that is 1 minus 4, and that is 1 minus 4, and that is minus 3.